So what Docker exactly is? Docker is actually, it is, you can call it a platform. It is similar sounding to virtual machine, but entirely a different thing also. Okay, I'll tell you what. It is a say it, you will have to install a layer over the operating system. No hypervisor comes into picture. Okay, say your operating system is Linux. Over it you install certain packages which which deploys a layer which can be called a platform to deploy other containers. Now, what are containers? Containers are small enclosures. They are not exactly virtual machines. They can act like virtual machines. Like uh, it can behave like a separate virtual machine, but actually it is not. It runs as a process in a Linux or a Windows server, but it can completely replicate an environment which is similar to a virtual machine. You will think that it is a different system altogether, but actually it is not. It is using your own system's kernel only. Okay, but it can replicate or emulate the environment. So it is more or less an emulator of a certain OS environment which will run closely connected to the Linux kernel, okay, or Windows kernel, wherever you install Docker. Okay, so what Docker is, it is just a layer or a platform which will be installed over your own virtual machine or the bare metal hardware which you are using. So there it will allow you to replicate other operating systems, and you can immediately package containers with whatever applications you want. So what does this picture say? This, it's an open platform for distributed applications. Like, let me give you an example. Say you have a scenario where say you are in a company which is producing Android apps. Okay, so Android is more or less written in Java and it is compiled. Okay, so when compiled, it gives us a APK file. Or say we have a Java application which can be compiled into a ware file which we run in a Tomcat server and run it as a website. Okay, so what do we do in a normal scenario? Even if we have a virtual machine, what do we do? We say we have a pipeline where in Jenkins which will automatically pull the code from the developer which they have put in GitHub or any Git repository. Code comes, code is getting compiled. We have all these tools like Maven and Ant. Say that that's the scenario where you have the code built. You have the jar file or whatever deployable is there. Now where to deploy this file? For that, say we need a Apache server or a Tomcat server. So in normal scenario, what will happen? You have to ask your system admin to build a Tomcat server. So what he will do, even if he has a virtual machine and all, but still he will have to install over it. He will do yum install Apache and all the required packages, Java and all he will put and then install it. Okay, so that will take a bit of time, and after that only you can test. Now once the code is tested, again you have to write another script to clean up the area where you are testing the code. Otherwise the old code will be there, and then the new one which comes through the pipeline to be tested will get affected. So you have to check all these things. So that makes the things difficult and slower, isn't it? Because you have to again create an environment before testing it. Or even in production, say something goes wrong, you have to again recreate an environment and then attach it to production. So that takes time. So Docker, what happens? It provides a very quick setup of everything. Now I'll show you how you have all done Apache server installations. If you have or Jenkins installation you might have done, you saw how much time it took. At least even if you are very good in Linux and do everything fast using scripts, it will at least take 20 minutes or something. But in case of Docker, if you have a Docker image ready, it is just a matter of seconds to launch an entire environment. In order to run a virtual machine, what we did, we installed an hypervisor. We have this Oracle VirtualBox which contains a hypervisor. Only when that is there, after that we can create the virtual boxes. or we have to install VMware, so it installs a hypervisor. Okay, so we need a layer which will allow us to host virtual machines. Similarly, to get Docker running, we have a software called Docker Engine. Okay, so Docker Engine, what it does, it will closely couple with your operating system's kernel. Okay, let me tell you just a few things about how it works. In Linux, the kernel have a portion called C groups. You can search and read about that more. What it does, I'm telling you. C groups will control the amount of resources that is provided to a certain process. Okay, before Docker was invented, C groups was there. C groups was a part of the Linux kernel from a long time. Okay, what was its use? It used to allocate a certain amount of resources to a certain process. Okay, now this Docker, people who develop Docker, they use this feature of the Linux kernel to develop a process which can take certain amount of resources. Like what I am telling when I am referring to resources is, say what happens when we start a virtual machine. We allocate certain resources, that 5 GB RAM for this Docker server, and then 40 GB hard disk, and then this much of total network cards, and all. We specify all these resources, and then only we can build a virtual machine. Similarly, since I told you Docker runs just as a process in a Linux system, so just like a daemon or a process, say we start Jenkins. How do we start? Systemctl start Jenkins. So it starts a process called Jenkins. Or we start Apache. It starts a process called Apache. Similarly, Docker has been written as a daemon or a process. When that process starts, it talks to the C groups module of the kernel in the Linux operating system. So the kernel will allocate it a certain resources. So that resource will be used to launch a certain Docker container. So container is like a virtual machine, but not a virtual machine. You should not ever tell anyone that. Most people confuse it, like they say it's like a virtual machine which is lightweight. This is the normal answer which I get when we talk of Docker. But no, it's not. It's lightweight, true, but it's not a virtual machine at all. It's just a platform. You can just talk Docker as a platform which closely couples itself with the Linux kernel or the operating system kernel where it runs, and using C groups, it can allocate certain resources and run packaged applications. Packaged applications means you already tell it that you do this one thing for me. It only does that one thing for you. Like say you want a web server, you you tell in the Docker file, there is a Docker file which that Docker file is a manifest. Manifest means it's just a set of instructions which tells what the Docker should do and how it should behave. Okay, so there we tell it that you behave like a CentOS 7 operating system. Inside it, you just run the Apache process, one Apache process, and inside it you put these files so that I can see this website. Like this, we give an instruction, and then that Docker process runs a container which will do all these things. Say we ask it to run Jenkins inside and make it available on a certain port. So when we build that Docker file or compile it, it gives us an image. That image will do this certain things for us. Okay. So from this screen, what are the takeaways? What is Docker? As I told you, it's a distributed platform where we can build Docker images to run as containers which are aimed at a certain task. Okay, and how it works? It works with a kernel module called C groups. That module allocates resources to the Docker directly from the Linux, I mean the operating system.